with a group in 2016 in Bangalore, and I would like to keep being engaged with the community. As some background about me, I was born in India in Nagpur, and then I was brought up in Yavatmal, which is I think it's very central Vidarbha area, and I pursued my engineering at Vishwakarma Institute of Technology in Pune before coming to United States for masters and PhD. So I've I have strong roots in India. My parents still live in Nagpur, so I do visit India quite a bit, and I feel lucky to have had a very strong educational foundation in India to help me develop a good research career here. I'm always looking for ways to engage with the Incosi India community. So this is a conversation. This is not a one-time presentation, and I would like to keep engaged with the work that is happening in India, and also if there are any students interested in research, or if there are any research opportunities that grow organically as we keep the conversation going. So today's talk will be very much geared towards my work on developing model-centric framework and approach for complex system policy. So let's see, let's go to the next slide. Yes, I think, so we'll just do a quick poll on MBSC and what's everybody's background on MBSC, so I can gear my talk accordingly. So Ms. Stuti, will you be able to do the poll now? Or?
Yeah, I can launch the poll.
Okay. So yeah.
So if you're using Zoom over browser, I think that's when you don't see the poll. But if you're seeing the poll, please respond. I do see a lot of responses coming in.
Oh yeah, same here. I can see them. This is pretty cool. It's very live, and it's pretty cool to see that everybody has kind of some experience. I guess, yeah, that some experience sort of goes 52. Yeah, that's pretty good.
There's a few more to trickle in. I'll stick for maybe a few seconds.
Yeah. Yeah, so the agenda today is sort of get to know the audience a little bit, and then go into why model and why did we, as in my research team, model, what has been done before, what we did, and then our results, sort of highlighting what we've done.
So I'm going to end the poll now.
Yeah, so it's about like 52% have some experience, 35 no experience, and then I have some experts, which I'll appreciate a lot of questions from the experts, and with some experience and no experience. So anytime in the presentation, if anybody has any questions, they can always type it in the chat window, I guess, and Ms. Stuti is going to help coordinate those questions. So okay, so it gives me a good sense, and folks who have no experience also can get engaged, because I'll try to make sure that everybody is engaged. So let me go back to my slides. So first slide, okay. Why model? So why do we care about modeling? So why systems engineers cared about modeling? And I think that the picture you're seeing is very much from Incosi model-based systems engineering workshop, which pretty much says that, okay, there were documents, and now the future is models. But I like these. I like the whole explanation of it. It uses ambiguity, vagueness, complexity, omission, duplication, buddiness, inappropriateness. And of course, it increases clarity, simplicity, understanding, communication. But very important, as we are getting mature, so as we are moving from no model-based systems engineering experience to some model-based experience to the expert experience, we are getting more into analytics. And the analytics have to be kind of catered to the models and not the other way around. And so why model complex policy? So this is something really very important, because what happens is you have an overlaying policy that sort of is dictated by administration, government, and quite frankly, if you're an electrical engineer dealing with small components, you really don't have to worry about what the governmental policy is. But when it comes to systems engineers, because we handle such huge, such complex, such infrastructure related projects, that policy kind of plays a major role in what we can implement. So the graphic you see shows that changing government, changing philosophy, changing technology sort of influences the policy. Then you have policy X that influences policy Y, that influences policy C. And then you also have regulations. And then you build your complex system policy down there. So why should we model policy? Pretty much the same reason why the systems engineers move from document-centric to model-centric, is to reduce ambiguity, vagueness, complexity, omission, duplication, wordiness, inappropriateness, and of course, increase clarity, simplicity, understanding, communications, and huge, huge, huge analytics.
I'm sorry to
So
interrupt you. There is some static noise coming from your end. So could we try maybe without your video? That may improve in the voice audio quality coming through. Thank you.
yeah, because it shows an eye for some reason for my microphone too. Is this better?
Yes.
Okay. Okay, so let me go back. Okay. So when Ms. Stuti asked me for doing this webinar, I wanted to customize it to the Indian audience. And one of the things, one of the major things, and if you see my example, it is related a little bit to healthcare. But one of the things that I thought might be applicable, again, I'm not an authority, but it might be applicable, would be the Aadhaar card system that India has come up with, which is a great system of authenticating the identity of the person. And keep in mind that that whole complex system is being developed during this administration and with certain philosophies in mind and certain folks in mind. And it took in a lot of investment from the government to actually build a nationwide systems. I mean, we did develop and fail in the past, but this was something that was consistently developed over time with significant government investment. Now, what happens if there is, let's say, some change in governance over here, or maybe a new technology, a better technology is available, and so we have some change in regulation, and then how do we handle the complex system down here? So there are a couple of questions that you want to ask in this domain with regards to Aadhaar card is, what happens if we find that there is a policy gap that allows the system to be open to cybercrimes? Can we trace it to the component in the system? Can we actually calculate the impact of it? And another thing that I want to reiterate is that policy, what I mean by policy is something of a written document that you have to follow. I don't deal with developing policy, and I don't develop with implementing policy, although some of my projects are related to policy implementation. But in this particular scenario, when I'm talking about policy, it is the written document. And that's another thing. So India has multiple languages. Multiple languages have multiple interpretation. And so when this policy becomes a regulation, how do we handle it at the complex system? That's another thing that we don't know. In fact, my dissertation is in software code quality. And I spent about a year trying to analyze natural language and trying to convert the software code into quality characteristics. And one of the things when I was doing some background research on natural language analysis, one of the key experts, John Soa, says that if everything was written in Sanskrit, we won't have to do any natural language policy. But unfortunately, we don't write policies in Sanskrit or very rule-based languages. But we do have, but because natural language gives us the flexibility of interpretation, but at the same time, you do want to have a consistent interpretation of what the policy is because of the impact it causes. Another reason why we kind of need to do policy is, can we afford a new complex system every time there is change in governments? Or if not, how do we develop reusable components or modular systems related to policy components? So by this, what I mean is, recently we had, well, not recently, 4 years ago in United States, we had a major change in governance, and the previous administration built a whole healthcare system that was interconnected with each other. And the new administration, because did not believe in this, changed it or tried to change it. Not that we can afford all that changes that administration puts on us, but for a country like India, it's even more so. So you have to think about things from reusable, modular components that we can have, which are on the policy and can be traced to the complex system and can be modularized based on what the new policy is. That way, we reduce a lot of costs that comes into making changing a system or developing a new system from scratch, or especially the new complex system. So why did we model? So this is very interesting. The way this project came about was, it was a nice afternoon. I was sitting in my office and I had a meeting. Some guys from the Veterans Administration were planning on coming and visiting, and they had recently had a big scandal. So Veterans Affairs, for folks who are not aware of it, are the agency sits under the United States Department of Defense, but Veteran Affairs are for the soldiers who come back from or non-active duty Army, Navy, Air Force that need healthcare and other social services. So they go from everywhere, all the way from education to healthcare to supporting the spouses to I think they also do the community nursing home and end of life support to them. So they do the whole spectrum of support. So it's a huge undertaking. They have multiple hospitals all across the country. They have multiple community nursing homes. They have multiple educational community centers. They deal a lot with post-traumatic stress disorder. They deal a lot with, of course, general surgeries, but also with psychological issues and family support and things like that. So it's a multi, and I think it's a multi disciplinary complex system. Along with that, they also were, I think, the first one to have really good electronic medical records. And I think a lot of commercial EMRs have been modeled after the VA healthcare records. But but in 2015, they were having a lot of issues and with people gaming the system, and there were a lot of fraud that was associated with it, and there were a lot of scandals and newspaper articles. So they tried to put together a team of engineers to help understand what's going on. And one of the things that they found was the government accountability organization. So in US, we have the government accountability organization that is an independent body that evaluates risks and frauds and things that are happening in the government agencies, because we have such big government agencies that we have to have another agency that sort of looks is like a watchdog to these agencies. But one of the things that they had, the one major issues that came up over and over again was ambiguous policies and inconsistent process. And that sort of was where we came in, where they wanted to find out how do you measure, find out what defines policy as ambiguous, and can you trace it? So can you recommend changes to the policy based on ambiguity? So in our research, what we found is this is like a generic policy cycle. You start with agenda setting. So this is usually where the politicians come into picture. Then there is some sort of policy formulation. There is some decision-making implementation. And keep in mind, the evaluation just happens after the implementation. So that sort of raised a lot of eyebrows for us that, oh, really? IV&V is actually happening after the implementation. So that was interesting. And so in my really, I had never before that read any VA policy, and having read a ton of systems engineering literature, I was naive enough to think that, hey, policy might be like requirements, smart. Smart requirements. So that's like straightforward. What is it? Okay, now I'm phasing out on smart, but basically measurable, clear, accurate, testable. And those were all the assumptions that after reading the first policy went out of the door. So what we started doing is investigation on what is the Veterans Affairs policy process. And what we found is they typically do an editorial review of the policy document. Then there is some sort of peer review where peers sort of give input to the policy, and then it is sent to the central office in Washington, DC for final evaluation before the Congress approves it. So it's a very, very much related to I think the Congress approves all the changes in the VA policy because they appropriate the budget for this particular office. And it was interesting when I started asking people, what is the policy making process? So I didn't get any documents or any regulations that sort of helped me in that direction. But when I did my research, that is this the case with all government offices, and what we found is that Department of Defense does have some sort of issuance standards. So they do have a specific way in which you have to write the policy and you have to follow a process and things like that. So they were much better than the VA. VA didn't actually, it still doesn't have a very formal way of doing policy along with the formal analysis of the policy. So nothing like requirements. Can we replicate what systems engineering do? So that was where that kind of aha moment came in, where let's see if we can replicate this thing using systems engineering. And after much ado, we kind of thought of coming up with a framework and a process. So this was very iterative, the way it was developed. we modeled, and we also modeled what we were doing. So here is the framework for policy content modeling. Typically, your policy is a, sometimes it will let me, so usually this is where we have, so this is usually where our natural language policy sort of lives. Now, can we, so this is still not completely automated, but that's the hope for the automation. That's research. So can we automatically extract, kind of like, I think with systems engineering, at least with requirements engineering, most of the effort for the last few years have been focused on writing a structured natural language and extracting the requirements from the Word document directly into a SysML model. So can we actually move from natural language to a rule-based language, which then becomes the single source of truth? And can we do some sort of analytics, which can be based on the investigation question, and based on the investigation engine, can we actually update the document? Now, if all the electrical engineers there are thinking this is another of the feedback loop, yes, it is a feedback loop. So yeah, so this is a good framework, but it also required some process. Because what we found is when we are doing any sort of systems engineering work, if it is not tied with the process, then it ends up being disjointed sets of information that is not connected and doesn't have a purpose. Because so many times we come to a point where we ask this question, what am I doing? And so we develop the process in order to actually articulate what are we doing. So we start usually here with the source selection. And source selection is usually the source entity that we are trying to find. Now, in some cases, if we are lucky, we can actually find a source policy that is written and we can actually model that policy. But we found that policies sometimes are institutional knowledge, especially when it with systems engineering. That's very much true, because we have people that are retiring, and a lot of information is with them, and the policy or the process, they are the keepers of that knowledge, and there is no real document that captures that knowledge, or let's just say that it's very difficult sometimes to put those in words. So that's very important. So in source selection, you definitely need to define your selection parameters. What are you trying to model? What is the policy? What process are you trying to model? Things like that. You also have to ask a investigation question, that what is it that you are trying to investigate by doing this whole thing? Very important to define team members early on, because you do want to know who is going to do what. So who's going to go hunt for the policy, or do all those interviews to find out what the process is, or try to find what is the investigation question. And you definitely want domain experts. So usually as a systems engineer, you have no idea about healthcare systems. I didn't know anything about VA healthcare, and I didn't know anything about, I think now I'm doing 2 more policies with rural broadband, and I'm doing another one with public transportation, and I'm not the domain expert. So you definitely need a domain experts to either help you authenticate your modeling, if the modeling is accurate or not, and also guide you on saying that, hey, do select these policies and not these policies, or these policies are meant to be vague. And one of the things that I found over last 3 years is the bureaucrats have a tendency of keeping policies vague because they want the statement of operations or statement processes to be more specific or more customizable to the particular office or particular agency that is going to implement that policy. The problem is that if you have a super vague policy, the process becomes super vague. And if there is no success criteria defined between the policy and the process, we end up losing millions of dollars pretty much. So that's one of the key findings that we found. But anyways, modeling strategy, usually this is another thing that needs to be defined early on is, are we doing automation or manual? What we found in our research is if you have a policy document that is about 20 pages, usually a couple of people, humans, can manually model it. But if it is more than that, you definitely need some sort of automation help. Now, we've been successful in doing documentary level automation, but beyond that, we are engaging, I mean, it's an ongoing research, but we are trying to engage natural language people or software developers to help us in that area. Then you got to decide what is going to be your modeling process. Is it going to be iterative or big bang or waterfalls? You got to define some of that. I think it's usually good to define it early on because it really helps set the tone on or the rhythm for the project. Then selecting modeling technology. Now, I used SysML because I was familiar with SysML. I thought it, as much as engineers don't like SysML because it is not executable at this point, I like SysML because it is descriptive. Being descriptive helps bring a lot of stakeholders at the same page, and you can have meaningful discussions on specific structure and behavioral models and not everything else in the world. So for those reasons, I do like SysML because it's not executable at this point, but there can be some executable components to it. And then you have to define what that modeling construct will be. And this I think comes from the fact that what is your investigation question? Is it trying to find the ambiguity in policy, or is it to automate the implicit knowledge, or is it, I think in rural broadband, we are really just looking at defining trade spaces inside the FCC policy on where will be the space to actually build broadband. So you have to, and that modeling construct is very much related to your investigation question. Then comes the investigation. And of course, I have the process very linear, but it is definitely not linear. Everything goes all the way. Like it's a very back and forth. You kind of, depending on every project, it can be customized. This is a very generic way, but there can be a lot of customization associated with it too. So then comes the investigation. The investigation typically, at least with the kind of investigation we are looking at, and especially for this project, it's going to be focused on classification of gaps. So we spend a lot of time defining what is a policy gap, and then what is the importance or the weight or the impact that that policy gap is going to have on the actual complex system. So for example, let's say there is something that opens the system to cybercrime. Now that is a high impact gap that you don't want policies to have. So you want to have policy that states that the encryption should be 100% or something like that. And if it's not there, then there is a gap. So that becomes no success metric. And I'll go into detail on the classification. Oh yeah, and by the way, if anybody needs more background information on this particular research, I have an open source paper that I think in the end of the presentation, I have the link to it, and you can read more and feel free to ask me questions after the presentation. Sometimes you attend a complex presentation, you have some questions, you read up, and then those questions come up. So So identification. So classification is your gap classification. Then comes identification. So identification is usually going to the model and actually tracing the gap inside the model or any machine readable entity and connecting it to that particular entity. And I'll show you how we did it in our project. And then analysis. In analysis, we sort of coined the metric called policy toxicity. And while we were writing the paper, that was the biggest challenge. Is the reviewers were not very okay with the formula that is set up, but we set up a very simplistic formula so that when you have multiple people applying and using this methodology and this process, they can customize it to their domain. Because we don't know, I mean, we did it on VA policy and our customers were happy with it, but not necessarily everybody's going to be happy with it. And then comes the review. Now, model review and unbiased representation. So these are two really important factors. This is my verification and validation. Basically, all the models need to be reviewed by the domain experts to make sure that that the model actually represents the policy. And this can be varied. This can be as simple as looking at the model and saying it's fine, or going through every sentence of the policy and making sure that all the stuff is represented properly. And then when it comes to unbiased representation, this has to be developed based on a large number of subject matter experts agreeing that the representation is the accurate representation. Alternatively, in the world of AI and AI for SE, this might be something that an AI can do, where it can sort of develop some sort of rule-based or some sort of example-based learning algorithm that can authenticate that these models actually represent the natural language. And I think it comes from here, which will be the future. So usually this one is the longest one, so rest of my slides go quicker than this one. But this is the main main introduction to the policy, content, modeling, framework, and methodology. So here's what we did. So that was the introduction to the framework and the approach. And this is what we did. We sort of started with define select parameters. So we had 4 policies that the Veterans Affairs provided us with. Our key members were the research team at WPI, which included me along with a couple of my graduate students. And then the Veterans Engineering Resource Center, we had access to a couple of engineers there to help us with the authentication process. And then, of course, our subject matter experts were those engineers from the Veterans Engineering Resource Center. So this was pretty much our source selection. Then came the modeling strategy. So we chose, because I had expertise in SysML, we chose SysML. You can choose Simulink, you can choose whatever modeling language you are familiar with. I think another very familiar modeling language is the the causal loop systems thinking one. Ms. Stuti, please let me know if I'm going beyond the amount of time. I can wrap these up faster if we need to. I think my main point.
We can go about 5 to 7 minutes, then we'll take questions.
Okay. Yeah. Okay. Yeah. Okay. Yeah. This should take 5 to 7 minutes. Okay. Manual and some automation. So we had 3 policies that were less than 20 pages, and then there was 100-page policy. So we did some automation for that. We decided to go with iterative versus bring bang. So we, I think, met like twice or thrice a week, and I would go through the models, and then we had another layer of modeling that happened with another level of review that happened with the Veterans Engineering Research Center engineers. We chose structural and behavioral diagrams in SysML because we did want to model the structure and the behavior of the policy. And so this is this is an example of a structural diagram where, and this is a very simple sort of just a document tree with the headings, and this can be very easily automated from extracting Word into SysML. This is another example of our behavioral diagrams where we have a start event, and this is an activity diagram, and then we go through the process, and then there are some conditions that happen, then there are some people who are applying this process. Then comes, I think, and this is the heart of this research, was this investigation, like I was saying, how do we define the gaps? And these are the way we define the gaps is there a hole in the process? Is there no trigger event? Is there misplaced trigger? Is there gap in sequence? Then there were some inconsistency issues. There were some ambiguity issues. And then we also defined the gap weight, which was high, medium, and low, structural and behavioral. And I think the full table is available on the paper. If you have any software engineering background or coding background, the way you have to think about these gaps is the compiler. If the code has gaps in the code, it will not compile. And so we were trying to just build something like that so that we can trace it to the exact location where the gap exists. So the next one is where, as you can see, this is how we trace the gap. So here we have a requirement to be defined as standard items. Again, it says to be defined as a standard item, but it doesn't say what do they mean by standard item? And therefore there is no metric for what is frequently used and established turnover rate. And this then was connected to this particular block, and we could extract these failures out, or these gaps out. So these were all the gaps that were located in this particular model. And we can also locate it here where we are actually defining that code. So the classification table that you saw in the previous slide is what is now linked here with that particular issue. And same, this was more for behavioral diagram. And that is, again, the failure. And then we came up with the policy toxicity formula where policy toxicity is equal to the sum of alpha I times ni divided by n, where t is the number of gaps, and I is the weighting factor, and n is the number of and then capital N is the normalization factor. So I'll show you an example of how we used it. So this is how we use this, where n is the total number of gaps, and then we have n1, n2, n3. There is alpha 1, alpha 2, alpha 3. And we can define what those gaps are. Now, that was one of the contributions where we could find policy toxicity per document. And also we can trace it to a particular page number. So if you see here, this is very important, where we sort of, here is where we can see the chapter numbers, section number, and the page number, and then the gap weight and the policy. So this was really very important to get the tag values out and calculate the policy toxicity. And then, of course, model checking required, like I discussed with you, we did it with the subject matter experts with the work, and we were not able to get a entire department to agree to the evaluation of the models, but so it is partially unbiased. And so this is how we work the policy component modeling framework and approach for the complex policy. Our future work is in automation, analytics, and evolution. And I think, so these are a couple of my websites which have more information on the current research. And the first, this is the link to the website, and then this is the link to the paper. And now I think I can take questions.
Okay, thank
Do you
you.
want-
Interesting presentation. I think we've not seen this sort of a topic in our webinar series, so definitely lots of questions coming in. I'll go with the first one. So there's a question from Kailash who wants to know, in order to model the policy, first we need to ensure that the complex systems are also modeled. Is that the right understanding?
Not necessarily, because not all complex systems are completely model. And so the challenge is to stick with just the policy and define your boundary condition or scope to the policy, because you really cannot, I mean, it will be nice if the complex system was more was completely model, but it's not necessarily at this point now.
Okay. The next question is from Mr. Hariom Singh, who wants to know, ambiguity and other problem of text-based environment might have been passed from natural language policy to SysML. How did you avoid or filter such issues?
So we called it out. So that was the whole deal. The ambiguity was called out, and it was then connected to the paragraph that it was in. And we kind of, I think our general rule of thumb was the verbs became behavioral diagrams, the nouns became the structure diagrams. And if the nouns and the verbs are off place, then that became ambiguity. That helps answer the question. It's still work in progress. I mean, I think as I'm going deeper and deeper, it's still work in progress, but this was kind of the general rule of thumb is if there is a mismatch, then you call, and we called it out. We selected those blocks as ambiguous. Or another way you can do it is put a block by itself and call it an ambiguous block.
Okay. The next question is from Sandeep, who wants to know what methods are recommended for stress testing the model while you are building, and is it in the nascent stage?
It's really, I mean, I think the only stress test is to run it by your peers at this point. Hopefully, as the technology matures to stress test the model, we'll have better understanding on what to do it. I would like to have some sort of automation, and if somebody is interested in that sort of research, I'd love to ship you my models and you can stress test them as much as you want, and we can write some journal papers out of it that will help improve the body of knowledge. Maybe in the next AppCosec we can have on our conference paper.
Mm-hmm. There's a question on, now I'm not sure if this is in your area, but are there any design modeling tools that you could recommend for UAV design?
UAV designs, I don't know. I mean, I think that's the best answer given the amount of time. I haven't really done much in UAV designs.
Okay. Yoga has a question. How do you make people understand your concept of modeling? What's the functionality in this modeling, and have you explored object process modeling? I've just combined Yoga's couple of questions that have come.
Okay, yeah. I mean, I saw the object process modeling stuff come by, and I I haven't really gotten into the object process modeling yet. I'm observing it because I did my dissertation of object-oriented design qualities. So I'm aware of object-oriented design and process modeling. The problem is that this is not an executable code, and it is, I think, the descriptiveness of the sysml makes it a little bit more appealing than following the rigid rules of object process modeling. I think that was the one thing. Which was the other questions that Yoga had?
Uh,
Do you have a sense of functionality here in the blocks that you do? So does a box represent a function in this policy?
Usually it is related to the if especially in this specific policy, it is related to if they are defining a process, and so the verbs become the functions sort of thing. So the activity diagrams sort of capture those functions.
Okay.
And then the organizationally, we, I think, represented functions and roles and responsibilities of individual or of the directorates. So like we had it had the whole organizational component to it, organizational diagram with this is the office and this is the function of this office sort of thing. And then those functions became activity diagrams. So that's how I introduced functionality in it.
Other question was on how do you explain this? You said that the
With
policy
great
makers, do they
difficulty.
understand?
Nope.
I find it so difficult to explain these engineering things. So how do you tell these government people about modeling? So I mean,
with great difficulty. So I've been I was lucky because I was dealing with Veterans Engineering Resource Center. They were engineers and they could see the value of it. But you're absolutely right, it's very difficult. So I'm now collaborating with the visual game design people, because one of the things we found is policymakers like to visualize, and if you show the visualization, it sort of helps. So I'm going to try it out this summer. I have a bunch of students and the game design people help me, because WPI also has a very good um, interactive media game design program. And so I have a couple of students that are going to do transportation modeling for public transportation, and I'm going to see if that sort of helps. So the back end is the policy and SysML, and the front end is a visualization of what is going to happen if they don't invest in public transportation sort of thing. So I'm going to try it out and I'll report back what happens. Yeah, it is with great difficulty, I have to agree.
Interesting. Next question we have from Nikhil, who wants to know, were there some aspects of policy that could not be described by the structure, behavior, or requirements? He's guessing maybe guiding principles or things like that.
Not really. Most of it is pretty easily categorized, because even if it is like a guiding principle or something like that, you can always throw it in a requirement and just say that has no metric. I mean, I'm just being facetious, but not really. I mean, if you have a natural language, it's not going to be poetic. I'm pretty sure poetry and the rhythm will be lost, but it will show up in some diagram somewhere. And the good thing is you can trace it. So you will be able to say, this is where it is.
Mm-hmm.
Because the model is linked with the document.
Okay. Kailash, is a follow-up question. Was the gap analysis done out of the SysML tool, and which tool was used for policy modeling?
So we extracted the gaps. The gaps were the ones that were tagged to the diagram. So we extracted the gaps into an Excel and just did some math on it, just a basic math on it. And for policy modeling, we used SysML, where we were reading the policy and modeling the policy, reading the policy and modeling the policy. So it was very basic thing.
Mm-hmm.
But I think now that there are like there is ton of research in digitization and stuff like that. I'm pretty sure, I'm hoping something will come up that can be easily be deployable.
The next question is something that I hear a lot in different forums. So, Hariom Singh wants to ask, MBSE methodologies look great and has a lot of excitement at the start, but as it gets deeper, people lose interest as well as they don't care if it is MBSE or any other method. So, what do you think is the main reason behind it? Is it maintainability, technical knowledge, or just sheer laziness?
Oh, the lazy. Well, I think it depends on your team. Like even for me, I mean, even coding is something similar where it gets boring after a while. I mean, you can code initially the coding team is really enthusiastic, and the IT team is like, let's go, we'll have new this, new that. What I think sometimes helps is moving from agile to some other process, or just having a. It's more related to productivity and increasing productivity for it, and it's related to any project that experiences lack of interest in any work environment. So you just have to find motivations, and I think with what happens with model based is because we focus so much on learning SysML and not so much on a process of actual modeling. So what will be the team, who will do what is going to be milestone 1, milestone 2, milestone 3, what will be the uh, what will be the stereotypes, what will be the naming, uh, what will be the configuration management of that of those models. And I think we don't spend enough time in the soft process areas of model-based systems engineering, and we just go dive into SysML, and then it's like, okay, what am I coding? What am I modeling? And people quickly lose interest, and the models become big and huge and complicated, and nobody likes to see such models. Like I always tell my students, I want more. Like I think my thing is, I don't want pretty pictures. I want good representation of the system. And I think that's, and some of those issues are related to motivation and process. I think I answered that question.
Yeah. One last question before we close the session is from Kailash. Was there any other behavior diagram generated as for policy modeling use case diagram could be more beneficial to drive the good stakeholder discussion? So,
yeah, actually there were plenty of those. Are just couple of SysML diagrams that I showed, but I have the whole repository of those models that were created. So it wasn't just one diagram. I should put that statistic. I don't have it on top of my head, but I think we created about, I want to say 10 to 12 models for each policy, or 10 to 12 diagrams for each policy.
okay. So Divyesh had a request that if you could copy the links that you showed in your last slide, although we would have the recording of this session,
Okay.
or maybe I can email them out to the participants for their reference. So we could do it.
Yeah, and I think if you even just Google the model-centric framework and approach for complex system policy and my last name, I think it should show up. But if it doesn't, I mean, it's always good to send it out. You can send out those links.
All right. So we just have the last minute, and I would like to take this opportunity to thank Dr. Shamnaz Virani for great presentation, interesting topic, and one that we have not seen or had such conversations here in Inkose, India. So, and as you can see from the number of questions and interactions, I think very intriguing conversation has started. Like you said, this is the first of the conversation, and feel free to reach out to that. I really appreciate that you're open to people reaching out to you for further collaboration and discussion on this topic. So thank you so much for your time, and thank you to everyone who joined in. Please watch out for further webinars. There are quite a few that are already lined up, and I also want to take this opportunity to thank everyone who give us good feedback through the registration sign up. Lots of great testimonials coming in. Thank you so much for your great feedback and participation. So have a good day, Shams, and have a good evening, everyone.
Yeah, thank you. And thank you so much for inviting me. This was very, very good presentation, and I hope to engage with you guys some more. In fact, keep me in the email list when you send out the webinar. I might join as a participant to some of the
Sure.
webinars.
Thank
All right,
you.
thank you.
Thank you. Bye, everyone. Thank you so much.
Thank you. Bye-bye.
Bye.